Okay, quick video manual on this thing. Okay, you have four sound sources, four oscillators. These four oscillators can be sound sources or they can also be LFOs. It depends on how you tune them. So once they go down here and you can see the LED blinking and fading, that's become an LFO. That's a low frequency oscillator, and that's too low for our ears to hear. It won't create anything high enough, but it can be used to modulate things. So it can be used at this stage. This one could be used to modulate the filter or modulate one of these other oscillators. So each oscillator has its own volume pot. So you have four right here, and these volume pots, they go to a mixer. Then you have the mixer goes directly into this filter. So this is the cutoff, frequency cutoff of the filter. This is the resonance or the Q of the filter. This is the CV input and the attenuator knob for the CV input for the voltage control. So each of these oscillators has an output so that you can modulate things strangely. So they're consecutive. So you have 1, 2, 3, 4. You have 1, 2, 3, 4 outputs. Then each one has a control voltage input and an attenuator for that input, which allows you to fine tune how the circuits react to the voltage. So they're also consecutive. 1, 2, 3, 4. 1, 2, 3, 4. These ones on the outside make a triangle wave when you have the lines lined up on the dual concentric pot. You can hear the harmonics. Then when you turn the dual concentrics away from each other, it changes the shape of the wave. These are saw waves all the time. Okay, this is a noise circuit with a random sample and hold, a random sample and hold. So I didn't bring the noise out to the panel because at first I did, but then I realized that this modulated sine wave is more useful, or modulated saw. It's a There's a AC coupled one and a DC coupled one, and so it's just kind of weird because it's always random. Because you can't really have a black hole without random. So here's just to be weird. Okay, so that's really weird, but this one is the other part of that circuit, and this is the trigger input. So if you have one of these two going slow, you go from the output of one of these two. Here I'm going to go from the second oscillator, number 2, and I'm just going to turn it down to where it's going slow, and it's going to be triggering this sample and hold now. The sample and hold is hardwired to this modulated sine wave, so it's always random. So it's not like a sequencer or not like a normal sample and hold, but we'll use it to modulate this thing. So we'll go to the last oscillator, CV input. I'll patch it in there, turn it up. can, well, we can slow it down, speed it up. So, you can use the same output from the sample and hold to modulate the filter. Then this is the filter input. The next, okay, so it goes from the edge. It's like high pass output, band pass output, low pass output, filter input. This input goes to this oscillator, and when you patch into it and you send it a really loud like drum signal or a trigger from a drum machine, this will become an envelope, and so you will be able to modulate the filter in time with whatever you're doing, or you can trigger the sample and hold in time, say give it 16th notes or whatever. If you're able to convert this signal, or if you have a sequencer with banana jacks, you can pitch these from a sequencer, or if you have a way to convert it from, like, say, like a BeatStep Pro, from the 1/8 inch cable to the banana, which is pretty simple. There's a power supply inside. It's powered by a wall wart. On the back, there's a banana jack going to the ground in case you want to patch with somebody that has a surge.